Go find a tap and turn it until it's just barely dripping. If you can't, picture one. Watch a single drop gather at the rim. It hangs there, fat and trembling, holding on. Then it stretches, pulls into a thin waist in the middle, and lets go. Splits clean in two. You've seen it 1,000 times. Here's what no one ever told you. That ordinary wobbling drop is the exact picture that let a 60-year-old refugee sitting on a log in the snow explain how to split an atom. No lab, no equipment, just that image and the nerve to trust it. Her name was Lise Meitner, and what she worked out and what was taken from her is something science has spent decades trying to set right. Lise Meitner was, by any honest accounting, one of the finest physicists of her century. Born in Vienna in 1878, she talked her way into physics when most universities barely let women through the door. She made it to Berlin, and there she found her scientific partner, a careful, brilliant chemist named Otto Hahn. The arrangement was simple and rare. He was the chemist, she was the physicist, and for 30 years they worked the same questions from two different sides. Hold on to that division of labor. It is the hinge the entire story turns on. It's worth knowing what she walked through to get there. In Vienna, girls weren't even allowed the schooling that led to university. She had to make up years of it on her own just to sit the entrance exam. In Berlin, when she first joined Hahn, she wasn't permitted in the main laboratory because she was a woman. She worked out of a converted carpenter's workshop in the basement and used a separate entrance. She went unpaid for years. Max Planck, who as a rule didn't admit women to his lectures, quietly made an exception for her, and none of it hardened her. By every account, she stayed generous, curious, a little shy. She just wanted to do the physics. For 3 decades, Meitner and Hahn pulled the atom apart together at the Kaiser Wilhelm Institute in Berlin. She became the first woman in Germany to hold the title of physics professor. She was respected, established, safe, or so it looked. And by the 1930s, their team had caught the obsession, sweeping every lab in Europe. Take uranium, the heaviest element they had, fire neutrons into it, and see what you make. Everyone expected the same thing, that you'd nudge it into something slightly heavier. New elements, just past the edge of the periodic table. Everyone was wrong, they just didn't know it yet. To feel why what's coming is such a shock, you need one picture in your head. At the center of every atom sits the nucleus, a dense, almost unimaginably small clump that carries nearly all the atom's mass. The force gluing it together is ferocious. That is the whole point of a nucleus. It does not come apart. Chip a tiny fragment off the edge. Fine, physicists had seen that. But crack one cleanly into 2 big halves? In 1938, that was simply not on the menu. Hold on to that. It's about to be violated. Then the ground moved. Lise Meitner was Jewish. For years, her Austrian citizenship had been a thin shield. The German race laws technically didn't apply to a foreign national. In March 1938, that shield vanished overnight. Germany annexed Austria, and in a single stroke, Meitner became a German citizen, trapped, subject to every law built to erase people like her. 30 years of work, a whole life in Berlin, and the door was being quietly locked from the outside. She had to get out. The trouble was, by then, getting out was nearly impossible. What happened next reads like a thriller, and all of it was real. With her Austrian passport no longer valid and the borders tightening by the day, a handful of colleagues arranged a quiet, illegal crossing. A Dutch physicist named Dirk Koster traveled all the way to Berlin and rode the train out beside her as if they were just 2 colleagues on a trip. She left with 10 marks in her purse, the legal limit, and a diamond ring Otto Hahn had pressed into her hand to bribe a border guard if it came to that. It was never needed. She crossed into the Netherlands on that invalid passport, on nerve and the goodwill of friends, and made her way to Sweden. She arrived alive, and with almost nothing else. No lab, no team, no language, a career cut off at its peak. Stockholm was safety, and it was exile. Meitner was 60, starting over in a borrowed institute that didn't quite know what to do with her. She missed her work, she missed Berlin. But here's the thing about a mind like hers. It doesn't switch off just because the room goes quiet. She kept up a steady correspondence with Hahn, still turning their uranium puzzle over from 1,000 kilometers away. And just before Christmas, 1938, a letter arrived from him that made no sense at all. Back in Berlin, Hahn and a younger chemist, Fritz Strassmann, had run the experiment one more painstaking time. Then they did what chemists do best. They identified, with great care, exactly what was left behind. And what they found made no sense. Not a slightly heavier element, barium, an element little more than half the weight of uranium. It was as if you'd thrown a pebble at a boulder and watched the boulder crack in half. The chemistry was airtight. Hahn trusted it completely. But he was a chemist. He had no idea how it could happen. So he wrote to the one person he trusted to know, his physicist. Sit with how strange this was. By everything physicists believed in 1938, the nucleus could not simply break in two. It was held together far too tightly. And so you had two facts that refused to share a room. Hahn's chemistry, which said the uranium had broken apart, and the physics of the day, which said that was impossible. Most people, handed a contradiction like that, assumed someone botched the experiment. Meitner assumed the universe was trying to tell her something. It was Christmas, and she wasn't going to spend it alone. Her nephew, Otto Frisch, also a physicist, also a refugee, came to visit her in a small Swedish town. The way Frisch told it, for the rest of his life, she would not let that letter go. So the two of them went out walking in the snow. He'd brought skis, she went on foot. And somewhere out in the cold, they stopped, sat down on a fallen tree trunk and started doing the math on scraps of paper, an aunt and her nephew, two exiles on a log, about to rewrite physics. And here is where our dripping tap comes back. There was an idea floating around physics that a nucleus might behave less like a hard little ball and more like a drop of liquid held together by surface tension, able to wobble and stretch. Meitner took that picture seriously. Imagine the uranium nucleus as that fat drop on the faucet. Feed in a little extra energy, and it starts to wobble. It stretches. It pulls into a thin waist in the middle, and once it's stretched far enough, the positive charges packed inside shove the two halves apart, and just like the water drop, it pinches off. Two smaller drops. Two new elements. One of them barium. But Meitner didn't stop at a pretty picture. She did what physicists do. She checked the books. She knew the two halves would weigh a tiny bit less than the original nucleus. A small amount of mass, simply gone. And mass is never just gone. Einstein had already told them where it goes. It turns into energy. She worked the arithmetic right there in the snow, and out came a number. About 200 million electron volts released by a single atom splitting in two. An almost absurd amount of energy from one invisible speck. The mass that vanished and the energy that appeared matched. Exactly. The drop had split, and the books balanced. They were right. Back in Sweden, Frisch wanted a name for the thing they'd just explained. He asked an American biologist what you call it when a living cell splits in two. The answer, fission. And so, in a short paper published in February 1939, Lise Meitner and Otto Frisch gave the world both the explanation and the word. Hahn and Strassmann had found the pieces in the lab. Meitner and Frisch worked out what the pieces meant. That is the honest division of labor. The chemistry and the physics, exactly as it had always been between them. Their paper is where nuclear fission gets its name. Here's the second half of why that paper detonated through physics. A splitting uranium nucleus doesn't only release energy, it also flings out a few spare neutrons. And neutrons are exactly what set the splitting off in the first place. So one atom splits, throws out neutrons, which split the next atoms, which throw out more neutrons. Multiply that across billions of atoms faster than thought, and the energy doesn't just add up, it avalanches. That's a chain reaction. It's the principle behind a reactor that can light a city, and behind a bomb that can erase one. Both roads start at the same wobbling drop. The paper landed like a struck match, and the race to build an atomic bomb began, tracing straight back to that walk in the snow. So when the call came, years later, to join the bomb work in America, Meitner's answer tells you exactly who she was. She refused. "I will have nothing to do with a bomb," she said. She had explained how the door opened. She would not be the one to march an army through it. And then came the part the story has never quite forgiven. The 1944 Nobel Prize in Chemistry, announced after a wartime delay in 1945, was given for the discovery of nuclear fission. It went to Otto Hahn. Only to Otto Hahn. Only to Otto Hahn. Meitner, who had explained the thing, named it alongside Frisch, whose physics turned a baffling lab result into one of the great discoveries of the century, was not on it. Not a share. Not a sentence. When the archives were finally opened, decades later, the reason turned out to be almost worse than malice. No grand conspiracy, just a committee that misjudged the work. A chemistry panel out of its depth on the physics that filed fission as a chemical discovery and quietly wrote the physicist out. Now, let's be fair, because Meitner always was. Hahn was a superb chemist, and that experiment genuinely was his and Strassmann's triumph. She never once claimed their benchwork as her own. But a discovery is more than the moment in the lab, it's also understanding what you found. Hahn had the result and no explanation. Meitner and Frisch supplied the explanation, the mechanism, the meaning, and the math. To honor one half and erase the other wasn't only unkind to a friend in exile, it was, plainly and factually, an incomplete account of how the discovery was made. Meitner never did get the Nobel. She got something slower and maybe sturdier. She lived to 89 sharp, admired, and over the years the record began to correct itself. The physicists who understood the work knew precisely what she'd done. Honors came, and in time, science paid her its rarest compliment of all. When a brand new element was forged, number 109, one of the heaviest ever made, they named it Meitnerium. There are only a handful of human beings in all of history with an element on the periodic table. She is one of them. The refugee from the log, written into the chart of everything that exists. When she died, it was her nephew Frisch, the boy from the walk in the snow, who chose the words for her gravestone. They don't mention fission, or the prize she was denied, or the bomb she refused to build. They say simply, a physicist who never lost her humanity. So the next time you watch a drop of water hang from a tap, stretch and split in two, think of her, a woman who lost her country, her lab, and the prize she had earned, and answered all of it not with bitterness, but with better work. She figured out how to split the atom, and she never once let it split her.